Good morning and welcome to this video on thermodynamics. See, thermodynamics is very important for your school examination and for your entrance examination or any examination you give. Thermodynamics is very important. Today's question is from NCRT, and before I do this question, first I will discuss the concept and explain you in such a manner that the concept will stay with you forever. So the important concept you need to work in this question is a concept of work. Let's read the question first, and then I will tell you how to solve these questions. These questions have potential of causing a lot of confusion in the minds of student, and today all your confusion will go away forever once you understand the concept behind the work done in a thermodynamic process. All right, so let's read the question. A thermodynamic system is taken from original state to an intermediate state by a linear process shown in figure so and so. Its volume is then. So this is the first process, right? It is moving like, okay, so I think they're referring to the linear interbilinear figure. It's all right. So this is the one which is being referred to. Its volume is then reduced to original volume from E to F. All right. So this is E to F. This is one by an isobaric process. All right. Calculate the work which is done, uh, total work done by the gas from D to E to F. So you have to calculate the work from D to E, okay, D to E, and then E to F. So you can see the words, right? It is from original state to an intermediate state by a linear process. Okay, so there is a linear process which is involved. Right? Linear means straight lines, right? Linear means straight line. The volume is reduced from the original value from E to F, right? This is the one which is the first linear process. As you can see, this is an isobaric process because the pressure is. So this is the isobaric process, right? And because the pressure is same. So let's first understand how do you solve these questions in which you have to calculate the work done. What is your aim? You have to find the work done. Your aim is to find the work done. Okay. See, the rule for calculating the work done is you have to do integration. I will use this English integration of pressure. Okay. With respect to volume. So this is the way you solve generally the work done, right? This is the integration. This is V initial. This is V final W, right? This is something you have to know if you're given equations. The second method is called as the graphical integration. Graphical integration means finding area under the curve, right? Or doing a definite integration but with the help of graph. So in our example, we are given you can see this is DEF. DEF is a triangle, right? It's a right angle triangle, right? So graphical integration is another method. It is basically finding area under the lines, right? So the lines could be these type of lines, the isobaric line or this particular line, right? So once you find the area under the lines, or you can say area under the graph, still you're able to find the work done. So this is the second method to find the work done. The first is integration of pressure with respect to the volume, which is very standard way of solving. Second is called as the graphical integration. The graphical integration also results in finding the work done, right? I hope this is making sense. Just wait before I start solving this, because it is very important that we first understand the concept. Solving this problem is very simple, but you will end up doing a lot of mistakes if you don't listen to this part of explanation, which is the most important part of it. This is the only channel which is giving you explanation No other website or channel will give you any explanation as to what is happening, what are the concepts involved. All right. The second thing, very important point you must understand is a lot of students get confused on the sign of work done. Okay, sign of work done. This is something you must remember. So, what is the rule for this? The rule for this, if you look into a graph, if a graph is moving rightwards, okay, if the line PV line is moving towards rightwards, so PV line, right, this is P versus, so for example, look at DE. DE DE is moving rightwards from left to right, right? So this is P and this is V. So it is moving from left to right. If a line is moving rightward, the work done is positive. If the PV line is, look at this line, EF, right? EF is moving leftward. If the line is moving leftward on a PV diagram, very important, I'm again repeating, sign of work done for PV graph. Leftward, the work done is negative, right? This is the sign convention you must apply, right? So first thing you must understand is the concept of work done in a thermodynamic process. How do you calculate integration of pressure? Second, or you can apply graphical integration. The second thing you must understand is sign of work done. If you don't understand sign of the work done, you will end up doing mistakes. Now I will start solving this problem, right? So let's say you have to calculate the work done by the gas from D to E and then from E to F. So let's calculate the work done by the gas from D. Now we will talk about solution, right? The first part was nothing but the solution. So let's say first calculate the work done from D to E, right? So D to E, if we look into D to E, you know, let's say D to E, what is the area which is under D to E, right? So the I'm talking about graphical integration or the area under the line. So, or the graph, right? This is a graph. So the area under D to E is completely this, right? This is the complete area under D to E, right? It is made up of a triangle and a square. So let's look into the area which is given by the triangle DEF plus the square which is EF. Let's call this G, let's call it H. So EFGH. Triangle DEF, okay? Triangle DEF, if you have to calculate the area, is half base. So if this is your some value which is, am I able to read this? Let me just rub this off so that I can at least read the value. This is the point H. Let me just rub this off, okay, using the eraser. So this is 5, all right, and let me start writing it again. So half, what is the size of EF, right? So it's 20 minus, this is 2 and this is 5. So this is 3. The base is 3, half base into height. Okay. So height is this much, 300 to 600. So the height of the triangle is 300 is equal to 450, right? 450. So you can see the Newton and volume. So this is 450 joule. Now, what is going to be the sign of triangle DEF? The area under DE is what we are calculating. This is positive because this particular D to E is rightward, right? This is moving rightward. Let's calculate the area under the curve EFGH. So area under the curve EFGH is the next one. We have to calculate the total area, right? EFGH. What is the area of this square? Plus, let me write this as plus. So 300 multiplied by 3. This is again 300 and this is again 2 into 3 is equal to 900 joules. So for this rightward moving line DE. So DE is moving rightwards, right? We are just worried about DE. So the total work which is done under DE is 900 plus 450 is equal to 1350 joules. Remember, we have not considered any other graph except DE. So the whole work we have done is for DE, right? So therefore, I did not worry about the direction of this. I'm just worried about what is the area under DE, and DE is moving rightward. Therefore, both the works are positive for DE, right? Only DE. Let's calculate the work done from DE, it says DE to F, right? So now we have to calculate the work done under EF also, right? So let's calculate the work done under EF. If you can see, EF is moving leftward, right? Let me just make it clear and remove this. So I am removing this, okay? So you can see that E to F is moving leftward. Leftward works are negative. So let's calculate the value. E to F 300, right? Let's write this as 300 multiplied by 3 is equal to 900. What is the sign I'm going to give it? Negative, because this is leftward graph. Leftward graph, right? What are you supposed to find? You're supposed to find the total work done from D to E to F. So what we will do, we will add the work done, which is work done from D to E plus then work done from E to F. This will give you the total work done from D to F. D to F. The sum of both the graphical integration. This is graphical integration number one. We got the answer as 1350. This is a second graphical integration. We got the sum as minus 900. So 1350 minus 900 is equal to plus 450 joules, right? So the net work done is positive. Calculations are never difficult. Solutions are never difficult. What is most difficult is explanation. This particular video will ensure that for the rest of your life, you will never forget that rightward works are positive. The lines which are moving leftward, the work done is negative. Rest is calculation of graphs or integral using integration calculus. So this particular numerical taught you how to find the work done and also how to decide the sign of the work done. My channel has 2000 physics videos, around 2000. Please go through each one of them. Each one of them will give you a basic knowledge and concept and numerous solved numericals for a particular chapter of class 11th and 12th physics. Do not miss a single video, because these are the questions and the concepts you will see in your entrance examination and school examination, board examination, state board examination, AP physics, IB board, ICSC. Everywhere you will see the same physics, same concepts. If the logic is strong, you can solve. Do not waste your time in just looking at solutions. They don't help. What will help you is explanation and logic and concept. So thank you very much for watching my video. Wait for my next video. I'm going to create some more videos on thermodynamics so that you can strengthen your concepts for each of the concept on the laws of thermodynamics. If you remember, the first law of thermodynamics has the work done in the equation. And today, what we did was, as a small part of first law of thermodynamics, we understood the concept of work done from calculation point of view and sign convention point of view. Thank you very much and wait for my next video.